Hey UMD, I have math lesson number 7 here for you today, and in this video we will do fluency, application problem, and then concept development, which means new lesson. All three of those things you need your whiteboard and marker or a paper and pencil. So if you don't have those things, go get them, pause, and come back. And then we'll do an exit ticket on Teams. Okay, so fluency, we're going to keep doing the same thing we've been doing. So parents, if you're watching this with your child and they're still struggling with this, please let me know so that we can do some work together online, because at this point we've done many lessons on this and this should be something that's starting to become pretty quick and independent. So I'm going to go through this a little quicker. Here are the steps to renaming fractions and mixed numbers with number bonds. If you need to review those steps, take some time, keep pausing while you're doing the work. Remember that fractions greater than 1 can be in the form of a regular fraction. Sometimes we call those improper fractions if they've got a numerator bigger than the denominator, or in mixed number form. Have the same two fractions in different forms. Sorry, my cat was just biting my toe. Sorry I made that funny face. Okay, here we go, 11/3. So over here, let's get ready. I want you to turn 11/3, or rename it, into its other form. So first tell yourself, what is that? Is it an improper fraction or a mixed number? Good, improper fraction. Change it into a mixed number, pause the video, go. All right, welcome back. Let's see what you got. Hopefully you got what I got. You said, that's an improper fraction. I'm gonna number bond the holes out of there, because 11/3 means that there are a bunch of holes in there. Imagine it on a number line. 11/3, would there be a hole in there? What fraction is 11? What fraction in thirds is a hole? Good, yep, 3/3. So I could number bond out how many of them? 1, there's 3/3. 2, there's another 3/3. How many thirds is that all together? Count by threes. 3/3, 6/3. We're almost there. Can we get another one? Yep. 9/3. Oops, sorry. 3/3. Another 3/3 pulled out would be 9/3. Can we pull out another one? Good. No, we can't, because how much would that be? Good. 12/3. So we've got to stop there. How many thirds do we have again? 3/3, 6/3, 9/3. Good. How many are left then if we had 11/3 to begin with? Great. 2/3. So now we're ready to count up our mixed number. So what mixed number does this improper fraction equal? 1 whole, 2 whole, 3 whole, 3 wholes, and 2/3. Great. Awesome. So you should have gotten 3 and 2/3. Say the mixed number with me again. 3 and 2/3. Great. All right, let's do the next one. Next one gets the opposite type of number bond, because the next one is what form? Yes, great. It's a mixed number. 2 and 1/5. Why is it a mixed number? What two parts does it have? Whole and fraction. Good. Number bond it. Now this time we're going to go the opposite, because remember what we want to come out with, what's the opposite kind? Not the opposite, but what's another way to say this number? 2 and 1/5. It's a mixed number. Yep, improper fraction. So we're looking for a fraction, and what's going to be special about that numerator? It's going to be good, bigger than the, yes, bigger or greater than the denominator. Awesome, here we go. All right, so let's first look at the whole number. Or sorry, pause, go figure it out, then come back. All right, welcome back. 2 is a whole number. But what fraction, unit fraction we're talking about? 5, good, fifths. So how many fifths are in a whole? Yes, 5/5. That should be coming to you real quick by now. So in 2 wholes, how many 5/5 are there? 1 whole is 5/5. 2 wholes is another 5/5. Is that all we got in this original mixed number? Nope, we have one more thing, right? 1/5. So together, 5/5 plus 5/5 is how many fifths? Remember, we're trying to get an improper fraction here. You got to add up all these fractions down here below. 5/5 plus 5/5 is what? Good. 10/5. Is that it? Are we done? Good. I hope you're like, no. We got to add that extra fraction. Great. How many is that all together? 11/5. Great job, everybody. Okay, so now I wish there was a way for me to erase this completely. That's a challenge to anybody. Figure out how can I erase this whiteboard completely in one quick step. All right, so let's switch to the application problem. Now there we go, that's easier. Now in the application problem, just hold down the mouse and move your finger. That's how you can erase it if you ever use that with your friends. Okay, today we're gonna keep working with how we actually do this in real life. Remember, I've been telling you, all the time we change improper fractions to mixed number in real life when we're thinking about time, like half-an-hour chunks, 15-minute chunks, measuring cups when we're baking or cooking, and then finally distances, especially when we're running. So that's the kind of problem we have today. Application problem, here we go. Fill in the blank when I pause. Jeremy ran 27 laps on a track that was 1/8 a mile. Jimmy ran 15 laps on a track that was a 1/4 mile long or 1/4 mile long. Who ran? All right, so let's get ready to draw. Visualize to help you figure out what to draw. Visualize the steps. One guy, and then summarize it without names or numbers. One guy ran a certain amount. They're on a track. He ran a whole bunch. Another guy, Jimmy, ran on a track. Were they the same size tracks? No, different size tracks. He ran 15. Now, just because one ran 27 and one ran 15, you can't quite compare it like that because it didn't run on the same size. Okay, so pause the video if you want to go solve it by yourself and then come back and check how I solve it, okay? Pause, and welcome back. Okay, so if Jeremy ran 27 laps on a track that was 1/8 long, well, if he ran 1/8 of a mile for one lap, and then he did 27 times 1/8, that's so easy, right? That's just 1/8 plus 27 times. Okay, so actually I'm just going to erase that and say, okay, so he ran 27/8. Cool. And then the other guy, he ran 15 laps. But what was his unit fraction? 1/4. So he ran how many? Yep, 15/4. Now you got to figure out, all right, well, how can I figure out which one ran farther? This is a comparison problem like last lesson. Which one of those is bigger? Well, last time we did this on a number line. What we did, though, was we said, okay, it might be easier, though, for us to think about it as mixed numbers first. So first, let's change these into mixed number versions. 27/8 in a mixed number bond it. Now this time I'm only going to do 2 little pieces of a number bond because I'm just going to count by the unit fraction to go faster. Hopefully you guys are starting to see you can do this too. How many holes are in there? What are holes in the language of eighths? Using the unit fraction 8? 8/8. So how many 8/8 are in 27/8? How many times can I count 8/8 before I get to 27? Here we go. 8/8, 16/8, 24/8. Getting close. One more would be too many. 32/8, that's too many. Okay, so back to 24/8. 8/8, 16/8, 24/8. Okay, that's 3 whole. So that means I can pull out of here 24/8, which is the same as 3 whole. So now I know my mixed number version of this will be 3 whole. And then let's figure out the fraction part. Well, if I had 27/8 and I take out 24 in the number bond, how many are left? 3/8. Oops, excuse me, I should say 8. Okay, so that means that he ran 3 and 3/8. 3 and 3/8 of what? A mile. Good. So it means he ran how many full miles? 3, and then a little bit more, almost half a mile more, okay? Now over here, 15/4, let's do the same, number bonded out, counting by the holes, 4/4, 8/4, 12/4. Next would be 16/4. That's too many, so let's pull it back. 12/4, which is the same as how many holes? 1, 2, 3. 3 holes. And how many are left over? 3/4. All right. So that means he ran how many? 3 miles and 3/4. Now, last time when we said, all right, now we can easily compare these two numbers on a number line. 3 3/8 and 3 3/4. Some of you might be able to visualize 3/8 versus 3/4 and already know the answer. Awesome if you do. But if not, think about it on the number line like we did last time. This number line has numbers that are in between what holes? 0 and 1? What holes is it between? 3 and 4. Good. Now we just got to figure out where 3 3/8 is and 3 3/4. So to figure out where 3/4 is, I got to chunk or partition the line up into fourths, which is always easiest by going half and then split those in half. So there's fourths. And where's 3 3/4? Here's 3, 3 1/4, 3 1/2, 3 3/4 over here. Oops, 3/4. Okay. Where's 3 3/8? How do we make 8s on this same number line? If we already have fourths, nice. Split those fourths into halves. It's something we do all the time to make 8s. That's the way to make 8s. How many 8s? 1/8, 2/8. You could also do this if you want, the little hops, 2/8, 3/8, 3 3/8. There's 3 3/8. Maybe some of you before, without even doing the number line, sorry, maybe you were thinking, the 3/8 isn't even a half, because 4/8 is a half. And then maybe you were thinking 3/4 is more than a half, because in 4 is 2, 4 is a half. So that's a really great way to visualize those famous benchmark fractions without even having to draw it. But now we can easily see which one is bigger, 3 3/4. So we would write our little compare symbol with the bigger side open to the bigger number. Who ran more, Jeremy or Jimmy? Jimmy ran more. Great job. All right, so when you do that problem in the application problem, come back to the video and see how we solved it. If you have any questions, there's no reason for anyone to get that one wrong. What I'm really seeing here in the assignment is, can you explain your thinking using race? You've got to use race, which means 3 complete sentences at least. But for math, it usually ends up being a little bit more because you need to tell the steps. All right, let's go back now to our new lesson, our concept development. Well, that practice we just did is very important to what we're going to do today. Because, I don't think that was that hard. You guys all know the steps, but it was kind of a lot of work. I'm going to show you a way today to compare fractions in an easier, a little bit faster way. And again, you already know all the steps, so I'm just giving you kind of a new way to use the steps you already know. Today we're going to use tape diagrams and common denominators to compare fractions, instead of comparing on a number line like we just did. And this is a clip from last week's lesson, so you probably remember those fractions from last week's lesson in that number line. So we already know how to use number lines, but as we see, it takes a little bit of work. So here's some faster ways. We could use tape diagrams, or we could use magic multiplication to find common denominators. Now, common denominators, we've talked about those before, but remember, common means the same. So common denominators just means same denominators, yes. Here's an example of two fractions with common denominators, 5/12 and 8/12. They have common denominators because the denominators are the same. Great. So what's another pair of fractions that has common denominators? 2/7. And I got to think of another fraction with 7 as the denominator. 5/7. Those are common denominators. Could even be 12/7. That's an improper fraction, but it's still a fraction. All of those fractions now have common denominators. What's a fraction that isn't a common denominator, that doesn't have a common denominator? 12, just think of a different denominator, 6. Okay? Those are not common denominators yet. They're not the same. How can we use common denominators? Well, 2 ways that are connected. I know you're going to like it because it makes fraction work very simple. When you get good at finding common denominators, all the fraction work that we've been doing becomes easier. So pay close attention and get some good practice today. All right, so compare each fraction using the different symbols here. Here are our steps. It's actually less steps, so it's faster. That's what I was telling you in the beginning of this lesson. It's a faster way to do it. Step 1. All right, when you're looking at 2 fractions or mixed numbers to compare, you gotta first decide, what am I gonna compare? Am I gonna compare the whole numbers? Or is that already kind of done for me? Do I need to compare fractions? Sometimes you might even want to change improper to mixed. You know how to do that though, so easy. Then step 2, make a tape diagram or tape diagrams to show the 2 different fractions. Make sure those diagrams are the same, good, same size. And then, or you could use magic multiplication to create common denominators. Both are fine. Some of you like one, some of you like the other. Maybe some of you like to do both to check. That's my favorite way to make sure you're right. And then finally, just use those tape diagrams and those common denominators to figure out, okay, which one is greater? Let me show you. All right, so I want you to work alongside me, so make sure you have your paper and pencil ready and write what I write. Here we go. Let's compare 5 3/4 and 5 3/8. Those are the same fractions from the last lesson. Watch how we do it faster now. So step 1, decide what to compare. Well, I'm going to compare 5 3/4, make sure you write this down, to 5 3/8 without this number line. Well, step 1 says decide what to compare. Luckily, the whole numbers are the same, 5 and 5. So, okay, yay, can move just straight onto the fraction. Which one's bigger, 3/4 or 3/8? You know that from the application problem already, but let me show you how you use this without a number line. Well, I can make a tape diagram. We love tape diagrams. There's one. Now remember, my next tape diagram should be the same size. There we go. Not longer, not shorter. They're not perfect, of course, ever, especially on this whiteboard, but okay, close. Now the first one I'm going to make into fourths. Cut it in half. Split them in half again. Do I have fourths now? Count them with me. 1/4, 2/4, 3/4, 4/4. Yes. And how many should I have shaded? 3. 1, 2, 3. 3/4. Let me label it. 3/4. Okay, and then 5 3/8. Oh, remember, I'm not comparing the 5s. Those are already there. I mean, those are already the same, so I don't have to compare them. How do I make 8s? Oh, it's kind of connected to the tape diagram above, right? Remember, I always make fourths first. I just use the lines from here and split those in half. 1, 2, 3, 4 new lines. That should give me 8. Let's double check to count. 1 8, 2 8, 3 8, 4 8, 5 8, 6 8, 7 8, 8 8. Hold. There we go. And how many of those should be shaded? 3. 1, 2, 3. Now it's real easy to compare here on the tape diagrams which one's bigger, right? Yeah, 3/4 is way bigger. Look, 3/4 is all the way, like all this huge chunk. 3/8 is this smaller chunk. Great, easy. So 3/4 is bigger. But that means that 5 3/4 is bigger. How can we use magic multiplication to even go a little quicker? Remember when we're using magic multiplication to create equivalent fractions? We're really just changing one denominator to become the other. We're asking ourselves that question we've done so many times. How could I make 3/4 into a fraction so that it has the common denominator of the other one. Could I change or convert 3/4 into a fraction that has 8 as the denominator? How could I get from 4 to 8? That's the question. You know that from magic multiplication. Yep, times 2. And whatever you do to the bottom, you have to do to the top. So 4 times 2 is 8. 3 times 2 is 6. So what does that mean? That means that 3/4 is equivalent to 6/8. Exactly. Now watch. Tape diagrams show us that. Before we learn magic multiplication, we always did that on tape diagrams. Here's 3/4. Could I make 8s out of this? Yeah. How do I make 8s out of 4s? We did it over here. Yep, I split those into 2 new sections. I could have also done a horizontal line in one line. How many now that I've made 8s out of what was 4ths before, how many 8s are there in those 3/4? 1, 2, there's that original line, 3, 4, 5, 6. There we go. That's what we got here with our magic multiplication. That's how we show it on a tape diagram too. That's how you use either tape diagrams to visualize or just go straight to the magic multiplication. I'm going to go straight to the magic multiplication in this next one because I know most of you in class really liked using that to convert one fraction into its equivalent fraction. Most of you were very good at that quickly, so let's just try that one on this new one, okay? 7/2 and 7/3. Let's compare 7/2 to 7/3. Which one is bigger? Which one is smaller? Now, some of you may be able to think about that just by thinking about the size of the denominator. If you can, great. Get your answer in your head and watch how I do it just to double check. 7/2 and 2/3. There's a few different ways I could do this. I could fix them each into whole numbers. Yeah, I don't have to do that though. Watch. Let's just use magic multiplication to find common denominators. So the question is, can I make 2 and 3 into the same number? Can I make 2 become 3 by multiplying? No. Can I make 3 into 2 by multiplying? No, definitely not. It's bigger. But what number could I make using both of them? Are you thinking what I'm thinking? 6. Can I make 2 into 6? Yeah, 2 times 3. Can I make 3 into 6? Yeah. 3 times 2 equals 6. That's because they have common multiples. That's really what that is. So can I turn 7/2 into a fraction with 6 as the denominator? Yes, we just said that. Then can I do the same with 7/3? Can I make it a fraction with 6 as the denominator? Yes. Then will my fractions have the same common denominator, 6? Yes. So how do I do that? 2 times what equals 6? 3. Yep. Whatever I do to the bottom, I have to do to the... Great. What is 7 times 3? 21. So what are the two equivalent fractions we just found out? Yep. 7/2 is equivalent to 21/6. Great. And then 7/3. 7/3 is equivalent to how many 6? Well, what do we have to do? Same thing as we did up here. Am I going to multiply 3 here? Oops. 3, the denominator 3 by 3 again? No, that's where you want to make sure you don't get tricked. 3 times what equals 6? That's what we got to figure out. 3 times 2. Nice. And whatever I do to the bottom, we have to do to the top. So I have to do 7 times 2. Awesome. What is 7 times 2? 14. Great. Now I can compare these two fractions because they have common denominators. This, now we're going to think of it as 21/6 7/3, we're going to think of it as 14/6. This is very easy to see now. Which one is bigger? Which one is greater? 21/6 or 14/6? Awesome. 21/6 is greater than 14/6, which means what about 7/2 and 7/3? Which one's greater? 7/2. That's how you use magic multiplication to find common denominators. What can you do to make two denominators the same? Sometimes you have to change one, sometimes you have to change both. It's very easy when you know all your multiplication facts and multiples and factors. Awesome job to people who memorize them all over the break. Steven, Tyrese, Rashid, they all learned a bunch over the break. Good job. Or over the school closure time. All right, so now you're going to do some of this practice here on math assignment number 7. If you still haven't done that vocabulary practice about mixed numbers, I guarantee understanding that stuff on the vocabulary will definitely help with this too, because they talk about making common denominators and stuff. All right, I hope you have I hope this is starting to feel easier for you. Parents, again, if you're watching this with your students, if your child is still struggling with this, please, please, please have them call me to do the work together, because I can definitely help them through it. Thanks, everybody. Have a very nice day. I'll see you soon. Love you all. Miss you all.